In one of our previous sessions, we talked about different types of materials and how we classify them into conductors, semiconductors, and insulators based on their conductivity. So now we are going to talk something that's exactly opposite to conductivity, which is called the resistivity. Materials in general have a characteristic behavior of resisting the flow of electric charge, and this ability to resist the flow of electric current is known as resistance. So resistance of any material is dependent on its resistivity, area, and its length. So resistance is equal to rho, which is a Greek letter. So rho is the resistivity of the material times the length of the material divided by the area, the cross-sectional area of the material. So here we have a list of resistivity of common materials. So as we said, this is exactly opposite, or it's inverse of conductivity. So conductors are supposed to have very less resistance, and insulators are supposed to have very high resistance or resistivity for that matter here, and semiconductors something in between. So if you see, silver has very low resistance, and copper, aluminum, and gold, all these are very good conductors in which we commonly use. And silicon and germanium or semiconductors, that is something in between. And we have paper, mica, glass, Teflon, and these are having a very good resistance. So if you see in general, like we will use, so paper is a very good insulator, and like say for making cables and things like that, like we dip paper in oil and like we use them as insulators for high tension cables. So these are some numbers. So let's solve a simple problem, or try to solve a simple problem and give you a better understanding of how resistance is calculated from the resistivity that is provided here in the table. So this is assignment 1, question 9. A bar of silicon is 4 centimeter long. So again, mostly you will have to make sure like all the units are consistent. So if the length is in centimeters, you will have to convert it into meters. And again, area, like when you get it, it's going to be in meter squares, not centimeter squares. So make sure you use all of them in the right units. It should be consistent. So here a bar of silicon is 4 centimeters long, so 4 times 10 power minus 2 meters long, with a circular cross section. So it's circular, it's like a cylinder. And if the resistance of the bar is 120 ohms at room temperature, what is the cross-sectional radius of the bar? So for a circle, the area is pi r square, and from the length and the resistance, and here another parameter is missing, so we also need to know the resistivity, which was available in our previous slide. For silicon, the resistivity is 6.4 times 10 power 2, and that is the resistivity of silicon. So here's the formula. So R, the resistance, which was like 120 ohms, equals the resistivity, I forgot, but like it's on the next slide, times the length, 4 centimeters, like 4 times 10 power minus 2 meters, divided by the area. Area is what we'll have to find initially to get the radius. So you move that here and divide the product of rho, resistivity, and length, and divide that by the resistance to get the area. So once you get the cross-sectional area, so the area is pi r square, divide the area by pi and take square root of that solution, and that should give you the radius, and that is question 9. And now Let's see one of the most important formulas in engineering or in electrical engineering, that's Ohm's law. So we know that like voltage is directly proportional to current, but there is a constant of proportionality called resistance. So this is the most important formula, and like it's a very simple formula. Voltage equals current times resistance. So V equals IR. So what happens is like the voltage tries to push the electrons, so that's the current, and ohms is the resistance that tries to stop it. And so to give you an example, let's say there's a beaker of water and you have a tap. So based on like how much water is there in the beaker, as we saw in the analogy before, so if the water is like really high, the potential is going to be higher, so which means more current. But let's say you have the tap completely closed, which means you have very high resistance, so water is not going to flow. But like if you open them up, so more you open, which is like more, the less the resistance, more currents flows through. So that is V equals to IR, Ohm's law. So the unit of resistance is ohms. So how do we define ohms? So let's say between 2 points of a conductor, if you apply a voltage or potential difference of 1 volt, and if a current of 1 ampere flows through that wire, and then that wire is supposed to have a resistance of 1 ohm. So that is Ohm's law, and that is ohms. So the unit or like the symbol we use is omega. Okay, so here we have a small problem to solve. So this is assignment 1, question number 10. An electric heater draws 10 amperes of current from 120 volts line. So the resistance of the heater is what? So you know the formula, V is equal to IR. So then like just substitute current and voltage and you will be able to find the resistance of that electric heater. So now there is something called Ohm's power law. So we know V equals IR, and we also know power equals voltage times current. So if we substitute voltage, which is V equals IR, or I equals to V by R in the power equation, we get Ohm's power law. So when I substitute I equals to V by R, so V times V is V square divided by R. So this is the power. Like if you know the resistance and voltage, just you square the voltage and divide that by resistance, you will get the power in watts. Watts is the unit of power. Likewise, if you multiply V equals IR, so if I substitute that here, I square R is the power. So if you know current and resistance, you will be able to calculate power. And let's do a small problem there again. So assignment 1, question number 11. A 100 ohms resistor is placed across a 9 volt battery. How much current flows through the resistor? How much power does the resistor dissipate? So to calculate the current, what do? V equals IR. So I equals V by R. So you know the voltage and you know the resistance. Just divide those and then you will get your current. And power equals V times I. You know the voltage and you know the current. If you multiply those, you will be able to get the power that is dissipated in this resistor. So that is resistance in a DC circuit. Things don't change in terms of resistance in an AC circuit, but again, we will not be dealing in depth with AC circuits in terms of, let's say, inductors and capacitors. There are other types of loads that are present, but like I'm going in the next session, I will explain how it works. But again, you don't have to, you can understand that, you can intuitively understand that, but you will not be getting more questions on those in your final assessment, or like even in the assignment. You will not get much, but you will have to know what happens when you apply alternating current to AC loads, like some practical loads, and what happens. You just the next session is for you to just understand that, but again, like, you will not be assessed on that in the final examination. So I just wanted to make sure that. So let's meet in the next session. Let's see how AC power is calculated for different loads.